As was promised, in this lecture we'll be doing some questions based on the concept that we learned in the previous video. So we in this video we have to compare the correct order of polarizing power. We'll start with the first question. We have to compare the polarizing power of various S block cations. Here we can quite easily state that the size of Li plus is minimum and that of C plus is maximum, and we know that polarizing power is inversely proportional to size. We have learned in earlier lecture as well. So the polarizing power of Li plus would be maximum, followed by Na plus, K plus, Rb plus and Cs plus. A similar explanation can be given for the next question. For Li plus and Be2 plus, the size is of Be2 plus is less as well as the charge is greater. So both the size and the charge are playing constructive role here, and so the polarizing power of Be2 plus will be greater. For Na plus, Mg2 plus and Al3 plus, size is greater. For Li plus and Mg2 plus, size is less. For Mg2 plus and charge is greater. So the polarizing power will follow this order. For Be2 plus and Al3 plus, we know that the size of Be2 plus is less, so its polarizing power will be greater compared to Al3 plus. For Li plus, Mg2 plus, Al3 plus and Be2 plus, we have the size of Be2 plus being minimum will have the maximum polarizing power, and Li plus among these will have the least polarizing power. For Sn2 plus, Sn4 plus, we will have due to the greater charge, Sn4 plus will have a greater polarizing power. And for the 9th question, similar reason: greater charge, greater polarizing power, greater charge, greater polarizing power, greater charge, greater polarizing power. Fe2 plus having greater charge will have a greater polarizing power. Cr6 plus will have a greater polarizing power compared to Cr2 plus, and the reason is charge. For Tl plus, Be2 plus and Bi3 plus, we see that these three cations are isoelectronic, and since Bi having the maximum charge, that is 3 plus, will have the maximum polarizing power. For the next question, Zn2 plus, Cd2 plus and Hg2 plus, Zn2 plus belong to 3D, CD belongs to 4D and Hg belongs to 5D. We have learned that when we go down the group, that is from 3D to 4D to 5D, we will see that the polarizing power increases in that particular order. So Zn2 plus will have the minimum polarizing power, followed by Cd2 plus and followed by Hg2 plus. And for Cu plus, Ag plus and Au plus, similar reason is there. Cu belongs to 3D, Ag belongs to 4D and Au belongs to 5D, and hence the order. Now for the next question, we have Cu2 plus and Zn2 plus. Zn2 plus having a D10 configuration and Cu2 plus having D9 configuration. So obviously we have learned that whenever we need to compare cations having D1 to 9 electronic configuration and D10 electronic configuration, then the polarizing power of cation having D1 to 9 electronic configuration will always be greater. So here Cu2 plus will have a greater polarizing power. For Na2 plus and Zn2 plus, we obviously see here Na is having 2 plus. Yeah, it's theoretically really difficult to produce Na2 plus, but anyhow, since here we have in the question, we should assume that Na2 plus can be formed, and so quite obviously Na2 plus being really hungry for electron in order to achieve the inert gas configuration will have a greater polarizing power. For Na plus and Cu plus, we have seen that Na belong to S block and Cu belong to D block. We have learned whenever we need to compare between S and D, D will always be the winner in terms of polarizing power. And similar explanation for the next question, S and D, D will be the winner. For between S and P also we have learned similar thing, so P will be the winner here. Between S and D, Hg will be the winner, Hg2 plus, and between Cs plus and Tl plus, we are comparing between S and P, so Tl plus will have a greater polarizing power. So this brings us to the end of this lecture. I hope you have learned, you have gained confidence that that whatever concept we have learned is really useful in solving the questions based on the comparison of polarizing power of different block elements. So with this note, we end this lecture at this point. In next lecture we will deal with another topic, that is polarizability, very briefly.